Welcome back. In this lecture, I'm going to show you how you can use Boolean expressions in a switch statement. Let's check it out. I'm going to create a simple code. It will tell us about whether a number is positive, negative, or zero. Let's type a switch statement again like this. As it switches condition, this time, instead of a variable, I'm going to type a bool value, true. Okay, let's add a case clause like this. Let's assume that I is an integer variable declared somewhere. If it's positive, then the bool expression will yield true, right? Then it will be equal to the switch's condition because it's true as well. So it will be executed. Right? Okay. I want you to remember this. The types of the case conditions should be identical to the type of the switch condition, right? So since the type of the switch's condition is bool, so I can type a case condition as a bool expression. As you know, a bool expression yields a bool value. I can type such a bool expression because the switch's condition is of bool. Go guesses the type of the condition expression from this value. Just true. Now both the type of the switch's condition and the case's condition are bool. You can type any bool expression as a case condition. Okay, let's add one more case clause here. Okay, let's add another case clause to detect a negative I variable. Alright, now let's add another case for the zero. To do that, I can add a default clause instead of a case clause. It's because there are no more options left. A number can be positive or negative but can't be both, right? So it should be 0. And the default clause is great for detecting that. Okay, this switch statement works because Go runs the switch statement from top to bottom. It first tries the first case condition at the top, then it tries the next one, and the next one, and so on. And if none of the case clauses match, then it goes and executes the default clause. Of course, if there is one. By the way, one more thing is left to do. In Go, switch's condition by default is true. So you don't need to type true as a condition. Let's remove the true value here from the condition, like this. Better. Now it's more concise. The same rules still apply. Since the switch's condition is a bool value, so all the case conditions also should be bool expressions as well. Alright, now this switch statement is ready. Let's take a look at it inside the code editor. Okay, here it is. Let's change the comments to println calls instead. I'm fast forwarding. Alright. Okay, ready. Let's run it now. It says positive because the I variable is 10, which is a positive number obviously. Okay, now let's make it negative. And run it again. Now it prints negative. And lastly, let's make it 0. And run it again. This time it prints 0. It works. Good. Okay, you learned how Boolean expressions work with switch statements. See you in the next lecture. Bye-bye. Welcome. In this lecture, I'm going to show you how fall true in a switch statement works. First, I'm going to show you a code snippet without fall true, then I'll refactor it into a version with fall true statements. Okay, let's get started. Let's say that I want to create a program that will print a message depending on a number. Let me show you. Let's declare an int variable like this. When the I variable is greater than 100, then I'm going to print big positive number like this. Or if the I variable is less than 100, and if it's a positive number, then I'm going to print positive number. To reach this case, it has to go through the above case first. So here, I know that the number is less than 100, right? Because it already went through the above case first. Otherwise, I'm going to use a default case and I'll just print number. Since it reaches this case, it means that the number is either equal to 0 or it's negative. For this example, I don't care about the negative numbers, okay? Okay, now let me execute this program. It just prints big positive number. It's because the I variable is greater than 100. Let me run this inside the code editor as well. Here is the program. As you can see, it prints big positive number. Okay, now let's change the number to something less than 100, like this. Okay, let's run it again. Now it prints just positive number. It's because it hits this case first. I is greater than 100, so it yields false. Then it tries this next case, greater than 0. This case yields true, so it runs this case. Now let's change this number to 0. Okay, let's run it again. This time it just prints number. It's because it has tried all these cases. But all of them were false. So it gave up and just executed this default clause because there were no more options left. As you can see, in this program, I need to repeat this positive number and number values, right? Actually, there is a better way. I can use a fall true statement instead. Let me show you. I've removed the duplicated strings now. Now I'm going to add a few fall true statements at the end of each case clause here. First, I'm going to add a fall true statement here. Then I'm going to add another one here. You'll see why that I'm doing this in a minute, no worries. By the way, keep in mind that fall true statement should be the last statement inside a case clauses block, okay? Okay, now let me run this program line by line. Here is a line pointer. When it moves on a line, it means that that line is gonna be executed next. Okay, first it tries this case condition. Since the I variable is greater than 100, so it runs this case. It prints big. Now it's about to execute the fall true statement. What will happen when it executes it? Let me tell you this. When it runs the fall true statement, the program will directly jump to the next cases block. So here it will jump to the fmt.print without executing the next cases condition. Let's check it out. As I said, it has jumped to the print and printed positive next to big. So when fall true is used, it won't care about the next cases condition expression and it will directly execute its block. Here fall true is safe because I know that 100 is a positive number. So I don't need to check the next cases condition. So I've just let it fall true to it. Now it's on the next fall true statement. Again, it's gonna directly fall true to the default cases block as if it was never been there. So it has printed number. In the end, the output becomes big positive number without having me to repeat the strings. As you've seen, instead of the break statements, Go has fall true statements. In other languages, there is no fall true statement. Instead, they go to the next clause automatically. That's why they need a break statement. For example, in JavaScript, in a switch statement, if you don't put a break statement, it will execute the next clause automatically. However, Go doesn't need it. It's because, as I showed you before, Go adds the break statements to the end of each case clause automatically. Let me show you this code in the coding editor with different inputs. Let's run this as it is. It prints big positive number. Alright. Now let's change the number to 80, for example. Let's run it now. It prints positive number as expected. This is because this case condition was true. So Go has executed it, then it has fall true to the default clause. Now let's change the number to 0. Let's run it now. It just prints number. This is because both cases were false, so it has only executed the default clause. Actually, this was just a demonstration. It doesn't mean that I would do this in a real-life scenario, but it explains how fall true works. Actually, a fall true statement is rarely used, but sometimes it may become useful, as in here. Alright, that's all. Congrats! Now you know how to use expressions within a switch statement. And you also learned about the fall true statement. Thank you for watching and see you in the next lecture. Bye-bye. Welcome. In this lecture, I'm going to show you how we can use the short switch statement. It's very similar to the short if statement actually. Okay, let's check it out now. Remember this code? It just checks whether the I variable is positive, negative, or 0. As you can see, this I variable here is declared out of the switch statements block, right? But actually, you could declare it using a simple statement right inside the switch statement. Like a short if statement, a switch statement can also use a simple statement. Let me show you. As you can see, I just moved the short variable declaration just before the switch's condition. Now you may wonder, where is the switch's condition? When you use a simple statement, you also need to use a semicolon to separate the simple statement and the condition like this. Or Go won't be able to recognize that whether this is a simple statement or is just the switch's condition. Now let's type the switch's condition as true, since I want to find out a case condition which yields a true value. Let's take a look at it in detail now. As I said, this highlighted part is a simple statement. When Go get across a switch statement, and if it has a simple statement as in here, it would run it first and only once. Like a short if statement, the short switch statement also uses a simple statement. The same rules also apply like scoping. I suggest you to watch the short if lecture again to learn more about the simple statements if you don't remember them. Here are some example simple statements. These all are simple statements. You can also use expressions. For example, you can call a function. Alright, now let's continue. This is a separator, as I said. It's just a single semicolon token. It just separates the simple statement and the switch's condition expression. Okay, let's continue. You know this one. It is the switch condition expression. Now it's true, but as you learned before, you don't need to type it if it's true. I've just put it here to show you the whole statement with a separator. Let's remove it now. Alright, better. Actually, as the condition expression, true is still there. It's just hidden. So that's why you still need to keep the semicolon as a separator there. Alright, that's all. Congrats, now we know how to use the short switch statement. In the next lecture, I'm going to show you an example program. See you in the next lecture. Bye bye.